Okay, today we're working on Unit 1, Section 4, and we're going to solve multi-step equations. I'm just going to do a couple different types of examples for you, and I'm going to explain what I'm doing on each step in writing, and I'm also going to say it as I go. So solve multi-step equations. This is a lesson that you may need to watch the whole thing. You may want to watch parts of it, and you may want to write down I have 6 example problems and see if you can do them yourself, and then go back and see if you got the answers right and you did the work correctly. So there's a couple different ways you could do this. So let's start with the first one. Number 1 is going to be 5 times the quantity. That means put what's next in parentheses, x minus 2, is equal to 10. Okay? There's really the same 4 steps over and over again. And that's what I've put them down to. So I always say the first step when we're dealing with multi-step equations, you either want to distribute if necessary, get rid of your parentheses, or sometimes you have to do both, clear your denominator. And we'll do some with denominators too, okay? Okay, in this case, if you look, there's no denominator, so we don't have to worry about that, but we do have parentheses, so we do need to distribute. Remember, distributing means we're taking the number that's sitting outside the parenthesis. There's no sign between it, so there's an understood multiplication there, and we're going to multiply that by everything inside the parentheses. So I'm going to go 5 times x, and that's going to give me 5x, and then I have a minus 5 times 2. 5 times 2 is 10. And then I keep my equals 10. Now, just like all my other problems, when I work equations, I always draw a line so that when I say different sides of the equation, there's a left side and a right side. And that line down the equal sign keeps my equal signs in the same place, so it keeps me nice and organized. And then it also tells me which side I'm talking about. Okay, the second step is always to simplify each side if possible. So we look at each side of the equation, and we look to see if there's anything that can be put together before we start solving. You can solve without simplifying. It'll just create more steps. All right, so I look in 5x minus 10. Well, the 5x cannot go with the 10 because there's an x on the 5 and there's no x on the 10. So we really don't know what that number is. So since we don't know what that number is, we can't combine it with 10 in any reasonable way. On the right side of the equation is just a 10. So in this problem, number 2 is already taken care of. We don't have to worry about that. In step 3 is where we're going to start solving, okay? We are first going to try to get the variable by itself, and we're going to start looking at adding and subtracting to both sides of the equation. And the reason I wrote to both sides of the equation, because that's the rule of algebra. If you break the rules, you're going to get the problem wrong. So we're allowed to add whatever we want to both sides of the equation. We can subtract anything we want from both sides of the equation, but we want to use something that's of value to us. That's part of the game of algebra, is to see what's going to be of value to add or subtract to both sides. Well, in this case, again, I'm going back to what we did in single-step equations, or one-step equations, or two-step equations. The x is that variable that wants to be alone, so I'm going to make it red. And I want to see what's added or subtracted to that x that might get in its way. In this case, it's subtract 10. Now remember, anytime we're going to do something to both sides of the equation, you want to do the opposite operation. So we originally had minus 10, so I'm going to add 10. Oh, I don't want to do it in red because that looks like it's related to that. Let's do that in green. I'm going to add 10 to both sides. Again, notice where I lined it up. I lined it up under what it's the same as. It's the same as that plain old 10. I added a 10 to both sides, so that negative 10 plus 10 is going to go away and make that big fat 0. And then we're going to be left with 5x on this side of the equation. And on the other side of the equation, we're going to be left with 10 plus 10. Now, yes, we should all know what 10 plus 10 is, and we should all be able to do that quickly in our head. But if you cannot, please don't be embarrassed to pick up your calculator. Please use the tools that have been given to you. So 10 plus 10 is 20 here. Okay? There's no adding or subtracting left in this problem. So now we can go to our final step. And these are the same 4 steps in every set of equations. Now we want to see, is there anything we can multiply or divide to both sides to get the variable by itself? Again, we have to do it to both sides of the equation because that's the rules of algebra. To keep it the same, we have to do it to both sides of the equation. Now in this case, we look to see what's crowding the x. The 5 is crowding the x. But you're not going to know what the opposite operation is if you don't know what's going on between the 5 and the x. So what's going on between the 5 and the x is multiplication. It's an understood there, okay? So what's the opposite? We're going to divide. So we're going to divide by 5. Divide both sides by 5. 5 over 5, if you don't know what that is, put it in your calculator. It's 1. And so great, now x is by itself because x times 1 is just plain old x. And then again, get out your calculator. 20 divided by 5. If you're not sure, you don't know your times tables, I'm not going to say anything. I remember most of mine, but every once in a while I'm tired and I need my calculator. 20 divided by 5 is 4. And so that's our final answer. X is by itself. And on the other side, we have what x equals. Okay? Let's do another type. Number 2. Switch to a different color. Number 2 looks like this. We're going to go through the same 4 steps, okay? Whoops, no parenthesis to start. It's x minus 2 divided by the entire quantity divided by 3 equals negative 6. Now, this is a one where on your first step, remember, you either distribute or you get rid of your fractions. And we call this clear your fractions. Okay, now you have to be careful with this one. I'm going to show you a couple different ones like this, but in this case, I'm going to clear my fractions. There's no parentheses. And in this case, this 3 in the denominator is underneath the entire side. Okay? So what I need to do is I need to get a 3 in the numerator. Well, if I have a 3 in the numerator, what happens? What does 3 over 3 equal? It equals 1. Okay, so let's rewrite this. X minus 2, well, we know that's in parentheses, really, over 3 equals, let me draw my line so I know which side is which, equals negative 6. Okay, if I want a 3 out of the denominator and it's in the entire denominator, I just need to multiply that side by a 3. Multiplying by the reciprocal, remember that word? So I'm going to multiply this side by 3, which is all well and good, but if I don't do what? I've ruined I have broken the rules of algebra. I need to multiply the other side by 3. Now be careful. What I see a lot of people do here is like, oh, well, there's parentheses, I should distribute. So maybe you don't need those parentheses. Maybe they confuse you. But what this is really meaning is this 3, the purple 3, is times the whole next thing. So maybe I do it like this instead. Maybe this makes more sense. Maybe I put the whole thing in parentheses. We're not distributing here. We brought this purple 3 in to get rid of the 3 in the denominator because 3 over 3 is 1. We don't then distribute it. You can't use it twice. You only use it once. And in this case, I used it to cross out the denominator. So that's going to be x minus 2. And on the right side is going to be negative 6 times 3. Now, a lot of you struggle with your negatives and positives, so just use your calculator. Negative 6 times positive 3 is negative 18. Okay? So sometimes the first step is going to take a longer time. Second step, simplify both sides. In this case, it's already simplified. The next step is add, subtract to both sides. Well, what is crowding the variable? The subtract 2. What's the opposite of subtract 2? Add 2. Now make sure when you put this in your calculator, you do it correct. This side we're left with an x. Put negative 18. The negative is down at the bottom of your calculator by the decimal. It's not the same as the subtraction key. If you try to put subtract 18 plus 2, it's going to give you an error message. Okay, so it's negative 18 plus 2, so that's negative 16. Now the fourth step here we don't even have to worry about, which is multiply, divide, but we already have x by itself. So sometimes we skip some of these steps, okay? But if you ever get lost in a problem, go back to the steps and see, did I miss a step? Did I skip a step? Did I double a step? Okay, that's a good way to look at it. Let's try number 3. Number 3 looks like this. 4x plus 2 plus 7 equals 3 times the quantity, x plus 5. Now, I'm not going to write out the steps anymore. If you need to have them at least written out once in your notes for you to be able to work on your classwork tomorrow. I'm going to step through them and I'm going to talk through them. If you need to write them down, you can. It's your notebook. The first thing I'm going to notice is, do I have any denominators? No denominators. Do I need to distribute? Yes, I do. This 3 was already there. The parentheses were already part of the problem, so I need to distribute. 3 times x, 3x. Plus, there's a plus there. Don't make that just disappear. Bring that down. 3 times 5 is 15. I'm just going to copy the other side for now because there was nothing we did to it. Now the second step is to simplify each side that can be simplified. That means combine like terms. We're not crossing the equal sign right now. So I'm going to look on the left side. Well, 4x can't go with anything because there's no other x there, but we have a 2 plus 7. These are the same. We know what 2 plus 7 equals. That's 9. On the right side, we have a 3x and a 15. Well, we can't add 3x to 15 because we don't know what x is. So 3x, we don't know the number, so we don't know what that gives us. So that we just leave as 3x plus 15. Now here's a step that's a little bit different. We have x's on both sides. Okay? So I'm going to use step 3 to add or subtract to deal with that. I want to get all the x's on one side. Now, you don't have to do it my way, but I do it this way for a reason. Let's see if you can figure it out. Write it down in your notebook if you figure out why I always do this. I'm going to move the 3x. Well, what's in front of the 3x? In front of the 3x is an invisible plus, okay? So we need to subtract 3x from both sides. We're not dividing, so the x can't come off. We're just moving it with it. And I'm going to move it to the other side. If I subtract 3x from one side, I have to subtract 3x from the other. And that has to go under that 4x, okay, because they're the same. Now let's see what I have. So 4x minus 3x's, you can't put the x's in your calculator, just 4 minus 3. That's left with 1x. Do I need to write the 1? I don't need to, but I can if that makes it understandable. The plus 9 we haven't done anything to, so we just bring that down. Now on the other side, on the right side, we took care of the 3x plus minus 3x, and that became a 0. So what was left on that side was a 15. We still have add subtract in the problem, so we are not done with the add subtract step. What wants to be alone? The x. What's crowding it? A plus 9. Opposite operation, minus 9. So we have x equals 15 minus 9, which is 6. I check to see is there any multiplying or dividing that needs to be done. There isn't because there's nothing attached to the x, so I'm done. Okay? I want to show you the next 3 problems are the first one, number 4. You have to have this in your notebook tomorrow. After that, I'm going to give you 5 and 6 to try on your own, and then you can come back and check my work. Okay? So number 4 is 8 plus 3n over 12 equals 13. Now, there's a denominator here. This looks different from number 2 because remember in number 2 there was a big long fraction line and the denominator was under the whole side. In this case it's not under the whole side, so this is a different type of problem. We still want to get rid of the denominator. To do that, we just multiply by a common denominator. In this case, there is only one denominator, so we're going to multiply everything by 12. So here's where you got to be really careful. I'm going to recopy the green. 8 plus 3n over 12 equals 13. And I'm going to multiply everything by 12. If you don't know why I'm multiplying by 12, come back to the original problem and look at the denominator. The denominator is 12. How do I cancel something out of the denominator if it's 12? I need a numerator of 12. Okay? So I'm going to show you this one slightly different. Okay? Because the 8 doesn't have a denominator, I'm not canceling, so I'm actually multiplying here. So 12 times 8 is going to be 96. Oh, did everybody see my mistake there? What did I forget to do? I forgot to multiply 12 on the other side. That would create a mistake, and then I wouldn't get the answer correct. Now, I'm not done here on the left side. I need to multiply the 12 by the 3n and the 12 in the denominator. Well, this pink 12 is in the numerator, and that green 12 is in the denominator. So if I have a 12 in the numerator and a 12 in the denominator, what happens to them? They cancel out. So I'm only left with the 3n. The 12 in the numerator canceled with 12 in the denominator. That was the whole point of multiplying by 12, was to get that 12 gone. And on the other side, if you don't know 13 times 12, that's okay. I actually did it in my calculator. I get 156. Now this looks a little backwards, but you still have to just follow my steps. Next step is step 2, is to simplify each side. Is there anything on each side that needs to be simplified? There is not, because on the left side we have a 96 and a 3n. Well, we can't put those together. They're not the same. And then on the right side we have 156. The next step is to add or subtract. Stop and think. What is being added to the n? It's the 96. And we always check in front of the number to see what its sign is, so we know what the opposite is. In front of 96, there's nothing there. So that's an understood positive 96. We just don't write that, which means I have to subtract 96 from both sides. It doesn't matter that it was first or second on the left side. Notice now I put the negative 96 on both sides of the line. I didn't try to put a negative 96 under 3n. That's on the same side. Okay? So then I'm left with 3n equals, and I got out my calculator and I did 156 minus 96. And I got 60. Okay? Final step. Is there anything multiply or divide to get the n by itself? Well, yeah. What's going on between the 3 and the n? Multiplication. So I need to divide both sides by 3. And so my answer here is n equals 20. Okay? Now here's what I want to do, because I don't want to make these videos so long. I'm going to give you number 5 and number 6 to try on your own. And then tomorrow in class, we'll check to see if you got them right or you need some more practice on these type. And the reason I'm doing these two is these are the harder type of problems, okay? When you have fractions in there, it takes some practice to learn to clear them. But I want you to try these two on your own. I'm going to give you the answer so you can kind of see if you got there or not. Number 6 is really a challenge because there's a negative in there, okay? And that can get a little confusing, so you got to watch yourself there. Okay, so here's the final answers for both of these. I want you to show the work to get to them. So the answer to 5 is p equals 16. And the answer to 6 is x equals 80. So what I want you to do is see what you can do and try to do those problems on your own. If you get extremely frustrated and you don't know the next step, go back and look at the steps I gave you. If you're still really frustrated, then we'll help you tomorrow when you come in, or whatever day you come in for the next class.